Okay, we're now recording. And let me try to share the screen here. So today is more word problems, who, his, applied max min problems. However, I'm going to end up doing almost all of them anyway. Okay, so on schedule is 10.4. Let me take a quick look at the schedule. So we are here, 15th. So I'll do 10.4. It's almost all word problems. Okay, there are 1, 2, 3, 4, 5, 6, 7 problems. I'm going to end up doing maybe like 5.5 of them. And that's like 70% already there. We were talking about doing 70% of the homework. I would have done most of it right then and there. Okay. All right, so we're still doing one section a day. Then next Tuesday, 11.1, Thursday, 11.2, and our next exam is the 27th. Okay. And if I move everything back up again, we're aiming for the last regular exam to be Thursday the 13th. I'm not going to write it yet, but that's the game plan for now. Then review for the final on the 18th, final exam the 20th, and then we're finished. Okay. All right, and let's see, Hugo, I got you. I think I already had you anyway. All right, so I will do some more problems, sort of like last time, applied maximum problems. After I think I've done enough, I'll stop, give you the quiz, and that's about it for today, all right? All right, so again, we're trying to minimize or maximize some quantity. We have a first derivative test. We have a second derivative test. We did that last time, and we're just doing more of the same. Okay, so 2 sections for similar stuff. Okay, so 10.4, 2, 3, 6, 8, 12, 15, and 19. Let me go ahead and show all of those to you. Okay, so it's my page 672. 2, I'm probably going to end up showing you this again anyway a little bit. There's 3. And let me look at my list. 6. Okay, there's 6. And where's 8? Okay, well, sorry for the crow in the book. It's the best I can do for 8. And actually continues up here. Okay, then what else? 12, 15, 19. 12. Okay, looks like we're trying to maximize revenue. 15, minimize fencing. And 19, optimization at a fixed cost. Right, so there we go. Okay, so I'll start you off with number 2. Projectile. A ball is thrown into the air from a building 100 feet high and travels along a path described by y equals negative x squared over 110 plus x plus 100, where y is its height in feet and x is the horizontal distance from the building in feet. What is the maximum height the ball will reach? Okay, makes sense. So you're throwing a ball up in the air, right? So it'll go up and it'll come down, and you want to find out where will it reach the maximum height. Okay. So here's all the essential information. Okay, so y equals negative, it said negative x squared over 110, but it's better to think of it as negative 1 over 110 x squared plus x plus 100. And you want to maximize this quantity. Okay. So take the first derivative. 2 times this is negative 1 over 55x, plus the derivative of x is 1, and derivative of 100 is 0. Double prime is negative 1 over 55. That is less than 0. Less than 0 means concave down, which means I will have a maximum. And again, am I looking for a maximum? Yes, I am looking for a maximum. Okay. Again, it's always going to be that way. If the book asks you to look for a maximum, it'll come out to be a maximum. They're not going to trick you. It'll come out to be a minimum. And I won't do that to you either. If it's supposed to be a minimum, it'll come out to be a minimum. But you're supposed to prove it the way you would prove it for these word problems quite often is to do the second derivative, although you could still do the first derivative test if the second derivative is too difficult. Okay, I think one of the problems that we have later involves that. All right, set y prime equal to 0. So negative 1 over 55x plus 1 equals 0. Move this over to the other side. So 1 equals 1 over 55x. Multiply both sides by 55. So x equals 55. That's the x, but it asks for the maximum height. So one key thing for any word problem is to answer the question. Okay, so for number 2, the end of problem 2, just before problem 3, what is the maximum height the ball will reach? That's the y coordinate. Okay, we have the x value is 55, 55 this way. So what's the y coordinate? I just plug it in. Okay, so plug in 55 here and 55 here. So negative 1 over 110, 55 squared plus 55 plus 100. Punch it in the calculator, 127.5 feet. Okay, and again, to save time, just take my word for it. I know you can punch it in your calculator, of course, but we won't take up class time for that. So we can get to it and give you more time for the quiz. All right, so that's number 2. Okay, number 6, productivity. A time study showed that on average, the productivity of a worker after T hours in a job can be modeled by P equals 27T plus 6T squared minus T cubed, 0 less than or equal to T less than or equal to 8, where P is the number of units produced per hour. After how many hours will productivity be maximized, and what is the maximum productivity? Okay, that's like last time, the first couple of problems, and that'll be like today's quiz. You're trying to maximize something. Well, the quiz will be maximum and minimum. Here we just want the maximum productivity on a closed interval. So that means for sure, I'm going to plug in 0 and 8. Okay, so that looks like, time is 0 to 8. So a typical 8-hour workday, right? You start at time equals 0, you work for 8 hours. When am I most productive? By this model, we're trying to find out when are we most productive. Okay, obviously not when we start. Okay, you can tell right away what happens for number 6. What happens when you plug in 0? Get 0 plus 0 minus 0, 0. And that makes sense. You just got to the office, or well, most of us aren't going into the office, including myself. You're working from home, but you just started, so you're not producing anything, right? You're not producing any output. So we're figuring out it should be somewhere later on. Okay. So here's the function. 27t plus 6t squared minus t cubed between 0 and 8. Okay, so I definitely have to plug in 0 and 8. 0 is easy. P of 0 is 0. Plug in 0, plug in 0, plug in 0, you get 0. Again, that makes sense. You just arrived at the office per se. You're not producing anything. You haven't got started or turned on the machines or whatever. All right, so I take the derivative P prime, 27 plus 12t minus 3t squared. And then P double prime is 12 minus 6t. Set P prime equal to 0. So I rewrote it so that it's t squared first and then t and then 27. So negative 3t squared plus 12t plus 27 equals 0. I'm going to factor out the negative 3. If I factor out the negative 3, it's t squared minus 4t minus 9 equals 0. And that, unfortunately, is not factorable. So if it's not factorable, quadratic formula. A is 1, B is negative 4, C is negative 9. Okay, so T is negative B plus or minus the square root of B squared minus 4AC all over 2A. You're welcome to put the quadratic formula again on any test that we have. All right, so negative 4 is 4, plus or minus the square root of B squared, negative 4 squared is 16, minus, temporarily pretend it's a minus, 4 times A, which is 1, times C, which is negative 9. So I have a double negative here and here, so I change that to a plus, right? All over 2A, 2 times 1. So this becomes 16 plus 36, which is 52. 52 happens to be 4 times 13. Take out the 4. So 4 plus or minus 2 radical 13 divided by 2. 2 cancels here and here. So 2 plus or minus radical 13. Now, square root of 13 is like 3 point something. I know the square root of 9 is 3, right? So this is more than 3. So I avoid the negative. I don't want a negative answer here, 2 minus something. So the only real solution that I want is 2 plus radical 13. Punch it in the calculator, it's roughly 5.6. Okay, plug into the second derivative. The second derivative was 12 minus 6t. 12 minus 6 times 5.6. I don't need to know the exact value. I can tell that's negative, right? 6 times 5 is 30-ish. 12 minus that is negative. Less than 0 means concave down, which means I have a maximum. It's about 5.6. All right, and what is that maximum productivity? I plug in that 5.6 to the original. So 5.6 goes here, 5.6 goes here, 5.6 goes here. So 27 times 5.6 plus 6 times 5.6 squared minus 5.6 cubed. Again, you can punch that in on your own. 163.7 units. Okay. All right, so I did the critical points, and now I have to plug in the other endpoint, which is 8. All right, so I'll plug in 8 here and here and here. So 27 times 8 plus 6 times 8 squared minus 8 cubed, which is 88. Punch this on your calculator, 88. All right, so I have my list. Your quiz today will be just like that. You plug in the endpoints and plug in any critical points. So 0 gives me 0. Again, that makes sense. You just showed up. You're producing nothing. Critical point was 163.7, and the endpoint was 88. So the minimum, which they didn't really ask for, but the minimum was 0, which again makes sense. The maximum occurs at 5.6, which is 163.7. Okay, so final answer, maximum productivity after 5.6 hours on the job, and you produce 163.7 units. So you're more productive at that particular time. Okay, the problem is finished. I'll just dig a little bit deeper. Okay, so if you work a typical 9 to 5 job, okay, so 5 hours in would be 1 o'clock, and then 0.6 hours, that's another 36 minutes. So according to this model, if you work from 9 to 5, they're saying you're most productive at 1:36 p.m. Okay, so you can take it or leave it. Okay, I guess it maybe makes sense that at the end of the day, 5 o'clock, you're maybe not so productive. You know, at the end of the day, oh man, I'm tired. I can't wait to get out of here, right? Okay, but according to this model, if you work from 9 to 5, I guess that would include lunch breaks or whatever. Well, if you're taking a lunch break, you're not producing anything either. But according to this model, if you work from 9 to 5 at 1:36 in the afternoon, roughly, that's when you're most productive. So anyway, you can take it or leave it. I'm not testing you on that, but that's what this model says. Okay, so it's kind of interesting. All right, number 8. Aim it for you right there. Okay, I can't do this any, but sorry, this is the best I can do because I'm hitting the document camera. But C is 25,000 X plus 870,000 over X, X greater than 0. Suppose that the monthly cost in dollars of mining a certain ore, blah, blah, blah. Okay. X is the number of pieces of equipment. How many pieces of equipment will minimize the cost? Okay, so minimize cost. Something we want to do. All right, so the cost function is 25,000 X plus 870,000 divided by X. And I want to minimize that quantity, right? So let's write that as 25,000 X plus 870,000 X to the minus 1. Again, for this kind of a word problem, we only want positive quantities. right? There's no such thing as producing negative quantities. All right, so first derivative of this is 25,000. Derivative of this is negative 870,000 x to the negative 2. Second derivative of this is 0. Negative 2 times negative that is this crazy number, 1,740,000 x to the negative 3, which I will rewrite as 1,740,000 over x cubed. And here's a nice thing about this again. This is always greater than 0 for any x greater than 0. Okay? We're only plugging in positive quantities. 1 million blah, blah, blah is already positive. Any positive cubed is positive. Positive divided by positive is positive. Second derivative positive means concave up. So if you look at concave up, you have a minimum. Are we looking for a minimum? Yes, we are. But yes, you have to prove it with this second derivative test. All right, so I set C prime equal to 0, and then I should be home free. So C prime was this thing, 25,000 minus 870,000. X at a negative 2, write it as over x squared, right? Equals 0. Don't like the fraction, so multiply both sides in red by x squared. 0 times x squared is 0. That gives me 25,000 x squared minus 870,000. X squared cancels out. Okay, move that over. 25,000 x squared equals 870,000. Divide both sides by 25,000. I get about 34.8. That's x squared. Take the square root. So x is the square root of 34.8, and that comes out to be about 5.9. So the answer is 5.9, reduction level. All right, quick reminder of what's going on here. So second derivative positive means concave up. Put that on your next cheat sheet, and that means also a minimum. Second derivative negative means concave down, means you have a maximum. Okay. All right, then let's see, problem 12. 12. In case you're wondering, the problem that I'm not doing is number 3, because I think you can figure this out on your own. Right, so look at number 3. You have the function x times 200 minus x dollars. How many trees will maximize the profit? So maximize that quantity, x times 200 minus x. And by the way, for number 3, I would advise you to multiply it out. If you multiply it out, then that avoids doing the product group. Right? Why do the product group when you don't have to? Multiply it out. I can't even tell you what that is, right? That's going to be what? 200x minus x squared, if you want to write that down for number 3. 200x minus x squared, and maximize that. So that's the only one that I'm not going to do at all. All the others I'm pretty much going to do. Okay, so 12 is a little bit harder. All right, you have a revenue function. R of t is 50t divided by t squared plus 36. T is greater than or equal to 0. R is in millions of dollars. T is in weeks. T greater than or equal to 0. Okay, so A, after how many weeks will the weekly revenue be maximized? So I maximize that quantity. Unfortunately, it's a quotient rule. Okay, once I get that answer, then I plug in to get the answer to B. What is the maximum weekly revenue? Okay. So here's my revenue function. What do I want to do with revenue? Maximize, right? I want as much money coming in as possible. R is in millions of dollars. T is in weeks. All right, so R prime, bottom, times the derivative of the top. Derivative of 50t is 50. Minus the top, 50t, times the derivative of the bottom, 2t. All over t squared plus 36 squared, right? All right, so I'll clean that up. So distribute 50t squared plus 36 times 50 is 1800. and then minus 100t squared. Leave that alone. So that comes out to be negative 50t squared plus 1800 all over t squared plus 36 squared. And I set that equal to 0. When is a fraction equal to 0? Top is 0. So solve negative 50t squared plus 1800 equals 0. Subtract 1800. Negative 50t squared equals negative 1800. Divide both sides by negative 50. Very conveniently, t squared is 36, which means t equals 6. Critical number. However, how do I know if I have a maximum or minimum? Now, I could do the second derivative, but look at this expression. You don't want to take the second derivative. You don't want to take the derivative of that thing. It's very messy, right? So you can always go back and do the first derivative test. Okay, so how do I do the first derivative test for max and min? We were doing that when we were doing the curve sketching, right? So I make a sign chart. Okay. So I lay down on my number line 6, right? Pick something over here, pick something over here. Okay. Now, the denominator is already positive, right? So the sign is completely determined by the numerator. Okay, so what's a nice number smaller than 6? 0. Put a 0 there, that's positive. Positive divided by positive, positive. Okay. And to fully exaggerate this and also to emphasize that, I don't care about the exact value, I want a number to the right of 6. I say 1,000,000. Why do I plug in 1,000,000? It should be obvious you get a negative quantity. Okay. 1,000,000 squared is super big. Multiplied by negative 50, it's a super big negative. So if I add 1800 to it, it has almost no effect. It's negative divided by positive, so negative. All right, so I'm doing the first derivative test. Increasing, decreasing. I was talking about roller coasters before. The roller coaster is increasing and then decreasing. That means I have a maximum. Okay, so that still works. And in this particular case, it's a lot better than trying to do the second derivative test. Okay, so I would only do the second derivative test if the second derivative was nice, which a lot of these other problems, it came out nice, but here it's not going to be nice. Okay, so the maximum occurs after 6 weeks, t equals 6. Then I just plug in 6 over here and 6 over here. 50 times 6 over 6 squared plus 36, 300 divided by 72, 4.17. But again, the units were millions. So if you just do 300 divided by 72, it's 4.17, but the units were millions. So $4.17 million is the way I give my answer. Okay. All right, so I'm done with this side of the paper. So I'll do my focusing thing again before I turn it over. On that. Middle column. Again, I usually get about three columns per sheet of paper on the side. Whoops, come over here. All right, there we go. Okay, so 15 and 19. And that's it. 15, minimum fence. 2 equal rectangular lots are to be enclosed by fencing the perimeter of a rectangular lot and then putting a fence across its middle. So there's my picture. If each lot is to contain 1,200 square feet, what is the minimum amount of fence needed to enclose the lots? Include the fence across the middle. All right. So here's the picture. Okay. I need you to ignore this temporarily. Those are the answers. But here's the original picture. You have X and Y. 1,200 feet squared for both parts. Okay. And you want to minimize the fencing. So how should I arrange it so there's minimum fencing? Okay, these happen to be the answers, but we're not supposed to know it yet. Okay, so 1,200 feet squared, square feet for both of those. So the total area is 2,400, right? 1,200 plus 1,200. That's equal to X times Y. What's the amount of fencing that I'm trying to minimize? And of course, if you minimize the fencing, that normally minimizes cost. Well, I have 1, 2, 3 X's, and I have 2 Y's. So the fencing is 3X plus 2Y, which I'm trying to minimize. All right, that has 2 letters. I only want a single letter. To do that, I solve this equation for Y. That's easy. Divide both sides by X. Y is equal to 2,400 over X. Right, 2,400 equals XY. Divide both sides by X. Y is 2,400 over X. Plug that back into here. Oh, sorry, plug it back into here. Should have my arrow come over here, really. But yeah, that is also Y. So the fencing function, I'll now call it A of X, is 3X plus 2Y. Here's Y. Y was 2,400 over X. Okay. So it's 3X plus 2 times 2,400, 4,800 over X. And that's what I want to minimize. Okay, so minimize this quantity. And naturally, again, for this kind of word problem, X and Y should both be positive. There's no such thing as negative distances, right? All right, so here we go. A prime, derivative of this is 3. Derivative of this is negative 4,800, X at a negative 2. A double prime, derivative of 3 is 0. Negative 2 times negative 4,800 is a positive 9,600, X at a negative third. Okay, which is the same as 9,600 over X cubed. Okay, we've seen that theme before. That's greater than 0 for all X greater than 0, right? This kind of a word problem, we only plug in positive. If I plug in any positive number at all, cube it, it's positive. 9,600 divided by it, it's positive. Greater than 0. Greater than 0 for second derivative means concave up, which means I have a minimum. Am I looking for a minimum? Yes, I am. Okay, so I just set the first derivative equal to 0 and go from there, and then it should be home free. Okay, so set A prime equal to 0. This thing, 3 minus 4,800 over X squared, right? Over X squared equals 0. Similar theme, clear the fraction, multiply both sides by X squared. 3X squared, X squared times this, X squared cancels out, minus 4,800. 0 times X squared is 0. Move over 4,800. Divide by 3. X squared equals 1,600. Square root. Normally you say plus or minus, but you don't have to because we're only positive. X is 40. Okay, Y is 2,400 divided by X. So 2,400 over 40 is 60 feet. Okay, so the dimensions are 40 feet by 60 feet. So that's what I mean by that. Okay. Then of course, for any word problem, you want to make sure you answer the question. The question is, what is number 15? What is the minimum amount of fence needed to enclose the lots? Okay, so I have to go to the hardware store and buy fencing. So how much do I need to buy? So the amount of the fencing was 3X plus 2Y. So I just multiply 3 times the X, which was 40, plus 2 times the Y, which was 60. So it's 120 plus 120, 240 feet. So final answer is 240 feet. Okay, 19 is the last one that I was going to show you. And then I would have done just about all of them. Except I wasn't going to do all of it. I need you to try something on your own, right? So I just set you up for it. 19. A rectangular area is to be enclosed and divided into thirds. So this time the picture looks like this. number 19, broken into thirds. The family has $800 to spend for the fencing material. Okay, so you can't spend more than $800. The outside fence costs $10 per running foot installed. The dividers cost $20 per running foot installed. Here's a picture. So the outside, $10 a foot. Those inside dividers, $20 a foot. What are the dimensions that will maximize the area enclosed? The answer contains a fraction. Okay, so I'll set you up with it, but I wasn't going to do all of it. Okay, and I'm done after this, folks. So, I mean, in terms of, you know, the word problems, since there were word problems, I decided to do most of it. I did 2. I talked about 3. I did 6, 8, 12, 15, and I'm doing, you know, half of 19. Okay. All right, so I decided to call these X, okay, the ones going this way, vertical, and decided to call this Y. Okay, so I have 1, 2, 3, 4 X's and 2 Y's, but they're not all the same cost. But the problem is to maximize the area, which is X times Y. All right, so here's the cost. I have $800. This is X, this is X, this is X, this is X, but this is $10 a foot. So that's 10X. This one is $20 a foot, 20X. This one is $20 a foot, 20X. This one is $10 a foot, 10X. Okay, so again, I have 4 X's. This one is $10 a foot, so 10X, $20 a foot, 20X, $20 a foot, 20X, $10 a foot, 10X. And then I have 2 Y's, which are both $10 a foot, so plus 10Y plus 10Y. Okay, so add them all up. 10X plus 20X plus 20X plus is 60X plus 20Y. Solve for Y. Subtract 60X. 800 minus 60X equals 20Y. Divide both sides by 20. 800 divided by 20 is 40. Negative 60 divided by 20 is negative 3. So Y equals 40 minus 3X. Pick this up, plug it right back into here, and you have your equation. Okay, so I'm trying to maximize the area, which is X times Y. Here's Y. So A of X is X times 40 minus 3X. This is Y. So 40X minus 3X squared. Okay, and you take it from there. So that's what you're trying to maximize with X greater than 0. And I think that's pretty easy to do. The first derivative and second derivative, that should not be that big a deal. Okay, and that's basically it. You will end up with a fraction, but that's okay. All right, I'm done, folks. So if you have a question, you can either unmute yourself or put it in the chat. I'll do my focusing thing, and I'll be done in a second. And if not, we'll go straight to our quiz, and then we're finished. Okay, so.
I have a question for number 15.
Okay.
Where did you get the 3X plus 2Y?
Where did I get the 3X plus 2Y? Okay, I decided to call this X. I decided to call this Y. So there are 1, 2, 3 X's. This one, the middle one, and that one. And there are 2 Y's. So the total fencing is 3X plus 2Y.
Thank you.
Okay, welcome. Okay, anybody else with a question? You can go ahead and say it or else put it in the chat. I'll go ahead and do my focusing thing in the meantime. There we go. Okay, and a reminder where we're headed. Okay, so I'm done with this. So Tuesday, 11.1, and next Thursday, 11.2. Those are not primarily word problems, so I'll be happy to hear. There might be just 1 or 2 word problems. Maybe the ones at the end tend to be word problems, but most of it are not word problems. Okay, and then the next exam will be a week from Tuesday. So 11.1, 11.2, test on the 27th. Okay, that's it. Any other questions, please? Otherwise, we'll go straight to the quiz. All right, so quiz time. Get your cell phones out to take a picture or be ready to do a screenshot. So here we go. Find the absolute maximum and minimum values of f of x equals x squared minus 10x on the closed interval from 0 to 7. Okay, so it's like the first few problems I did last time. I'll even tell you what to do to help you. Okay, what numbers do you have to plug in? You have to plug in 0. You have to plug in 7. In addition, any critical numbers. How do you find critical numbers? Take the derivative, set it equal to 0, right? And then you have a list. From that list, whichever is the highest y value, that's the absolute max. The lowest value will be the absolute minimum. So that's what it asks for. Okay. And let's see, next exam was the, what did we say? The next exam is a week from Tuesday. That's the 27th. Yeah, not the 29th. It is the 27th. Whoops. I'm moving everything up a day. Right? So never mind about that. Okay, I'll give you a few more seconds. Go ahead and start working on it, but I'll set up your breakout room shortly. And I should give you the ability to screen share too. So when you help each other out, you can share the screen as necessary. Okay, x squared minus 10x between 0 and 7. All right, I will assume that everybody has it now. So go ahead and get started with it while I set up the breakout rooms. I'm going to